Note that in the next video we will start programming the Arduino Uno board, but before we start programming that board, it will be good for us to be introduced to some additional components which we might use later. We're just doing a small preview of the additional components of the Arduino. Some of them we just talked about, like the relay, but I've not really shown you what those components are. So let's start with which component. We're starting with the servo motor. The servo motor, this one, it's called a servo motor. So with the servo motor, typically a servo motor looks like this. You will note that it has 3 lines, 3 wires, and what these 3 wires are, we have a brown one, we have a red one, and we have a yellow one. A brown one is the ground. The one at the center, which is red, is the VCC. You connect it to the 5 volts. And the one at the far end, which is the yellow one, is the signal line. That's the line that gives the servo motor instructions, whether to start, moving, whether to move and stop. And with this servo motor, you don't have to do other external connections to it, like the connections we talked about, the connections having diodes, because it's very complete. The connections have been done internally. Inside this plastic, we have diodes and we have gears which have already been done for you, so you don't have to add more external circuits. Just connect it direct to power without the diodes. So that is the servo motor. The next thing in our pack is now going to be the DC motor. The DC motor typically looks like that, and in our book the DC motor will look like this. This will be the DC motor. So with the DC motor, you will now note that the DC motor is not the servo, it's the DC motor. The DC motor is closely related to what we just talked in the previous video. We talked of the DC motor. It has the positive, that's the black side, the red side, and the negative connections. It has both of them. So the positive side will always be going to, in your connection, the positive 5 side of the connections, and this one will always be going to the GND side of your connections. And for this motor, it has a lot of coils inside it. This is what we are talking about. If you open this motor inside and look, if you zoom inside and just look at its internal connection, you'll see a lot of wires, and therefore this motor will need okay, I have moved this one, but I'll just put it back. This can be soldered. Later on in the latest videos, we will show you how to solder things, how to put things together. It will be very fun knowing how to attach wires together. So we'll just put it there. So for this one, at these far ends, between this side and this side, you have to connect a diode, and that diode has to cross in between. Let me show you an example. This side is the positive and this side is the negative. You have your diode like this. This side is the negative side of your Arduino having the band, not the Arduino, the negative side of your diode having the band, and this is the positive side without the band. So the negative side will always be connected to the positive side, and the positive side of your diode will be connected to the negative side of your diode. So before you use your diode, you have to either connect it this way on your breadboard, or you can just solder it directly. You can have it here like this. To solder is like to weld in electronics. To weld, you can just put it like that and have your wires come out. So in case when you have finished, you put the circuit off while it's still running, the current will be going round and round. And note that these diodes, they have just been, yeah, there are two diodes. I've been showing you two of them, it's not one. So this is how they look like. Yeah, just look like that. Let's put it this way. This side was positive, this side is black, negative. It's black. So this way, positive. So that's how you solder your diode to make sure that you have everything working correct, and you'll just have your line coming out. So that is all about the DC motor. Make sure when you're working at them, be very careful. Don't snap it, don't cut it, don't pull it. If you pull it, it will just cut like this. But if in case that happens, have no worries. In the other videos to come, I will show you how to do soldering. So we'll solder this one back there, and it should be very tight. To solder, just to put something like this. Let me put it this way so that you can see where I can zoom. Yeah, soldering is putting something like this. You see, this thing which was put here, it was soldered there. So in the later videos, we'll show you how to solder. And in case something is like this, or you have something you want to join or fix, or you have a diode you want to fix directly here and here, you just come and solder it directly. Okay. So we are heading right away to the next member of the pack, and our next member of the pack is called relay. A relay looks like this. That's the relay that you will be using. And the good thing, they are always having things written on them, and you can always see the rating, the power it supports, or everything. So when I zoom it much clearly, you will note that it's written 5 volts DC. That's what we were also talking about. So again, this relay, you will have to, in between the two lines that are powering it, these two lines are the ones that are connected to the coil. These others are just to do switching. A relay is just like a switch. You can put it this way. With a relay, it switches two things. When one thing is off, another one is on. You can have two bulbs connecting to one relay. So when you power the relay, it will switch on one bulb and the other bulb will go off. And when you power off the relay using these two, one will go to the positive and another one will go to the negative. When you power off the relay, the other switch will now come on and the other one will go off. So those switches will be connected in between those other three, and we will talk about these connections. We'll talk about all these connections later. Have no worries about them. But the one thing you will always note when you're working with relays, just make sure that you're giving the right volts. If it's written 12 volts, don't give it 24 volts. If it's written 5 volts, like this one, don't connect it to something which has more than 5 volts. It has its own coil. The coil, which we said has to be protected and has to be put, you have to put a diode in between, is in between these two. It's in between these two pins. So you have to connect it like this, something like this. So if you connect it like that, you have protected it from you've protected the reverse current from spoiling your circuit. So that's all about the relay, and we are going to the next member of our components pack, and this one is called the IC. I know you've ever heard of ICs. You've heard people talking about ICs, and you've seen them. An IC is an integrated circuit, and it looks like that. So they normally have numbers, and ICs do different things. What it means, an integrated, we have ICs for different things. They are inside radios, inside a lot of things. What ICs means, the integrated circuit means, it means that we have very, very many small circuits inside that. We have a lot of diodes inside there. We have a lot of resistors inside there. We have a lot of, some even have LEDs inside. So it's just a combination of very many circuits which have been made to be micro circuits, and it makes your work easier. That's all about the integrated circuit. We are now going to our second last member, and our second last member is the transistor. You are wondering what is a transistor. A transistor, they normally have their specific number depending on the purpose and the job the transistor is made for. A transistor is now like it's the same as a relay, but it doesn't switch two things. A transistor only switches one thing, but the switching ability of it is controlled by an electronic signal. Instead of you placing your hand there, like the push button you're pressing for you to switch, you just send some voltage from it. Maybe the voltage might be coming from a 13 volts or something, and it will respond by switching that thing on or off. So a transistor is a switch, and we will get to it later when we are working in other projects. And the last thing we are looking at is the temperature sensor. And you remember we talked earlier on about sensory organs, like your skin is a sensor. The same way with electronics, we can use a temperature sensor to detect, your skin can detect the temperature. But for electronics, if we want to know the amount of temperature, we'll use something like this. It's very closely, the shape is the same, it's very close to a transistor, but the goodness with them, they have very, very small writings in them. You will always look at those writings, and those writings are the ones that will tell you, is it a temperature sensor? If it's a temperature sensor, you'll see something like TM. If it's a transistor, you'll see a number like PN something or something, so, or BCC. So it's always good for you to look at them so that you know what they are. How they are being used, we'll come to that later while we are building our circuit in the next videos. So see in the next videos, we will start, we'll introduce you to the software to program the Arduino, and we'll start programming the Arduinos with simple programs like blinking the LED. You remember we just lit the LED, but we didn't blink it. So we'll do a circuit where we'll have our LED blinked depending on what delay we want. So see you in the next video.